What do you call it? The quiz?
Yeah, I think so.
Okay.
I don't know why. Just he doesn't want to open the iLearn on Safari. I don't know what's going on, but it's no big deal. So.
Okay.
Okay. Alrighty. So do you have it open, Kyle?
Yeah.
Okay, perfect. Alrighty. Actually, let me. Okay, so number 1 and 2, 3. Symbol for the true population proportion is
P.
Yep, P.
It's good old regular P.
So for 4 and 5, suppose it looks like I might need the calculator.
Now,
4 and
do
5.
we for this one, do we use P hat or do we use P?
So for number 4, if we're just looking at the requirements, yeah, we use. I'm pretty sure we use P hat.
Okay. Because on my notes, I think I just have it as P.
Oh, really? Maybe it is P. Let me look.
Yeah, I just have it as P. Either way, it's still true.
So the requirements on the web or the wedge player video thing says n times p hat has to be greater than 10, and then n times 1 minus p hat has to be greater than 10 as well. So
now, is that for the confidence interval, or is that So that's
the requirements for the confidence interval.
Hey, where did I put my pen?
Okay. What are you doing? With my phone?
My little cousin, my new little cousin, I was looking at him today and he started crying.
Oh gosh, that sounds exactly like this one 3 months ago.
Really?
She wouldn't even let me get close to her. She'd just like that. Who's that? That's you, huh? So let's see if we're to do the. Okay, go over there. Oh, you held on. Good job.
Okay, so this was my question. Are the requirements the same for the hypothesis test and the confidence interval?
You know what? I think. You know what? I wasn't paying attention to what they were really saying if they said there was a difference, but I think that was really the only thing I saw was the. My goodness. Was the p hat one, was using the p hat for the confidence interval, but I don't know for the hypothesis test.
Yeah. Look here.
Let's see. Yeah, I'm kind of looking through the video right now. You know what? Maybe they use the. You know what? I think what they said for the hypothesis test was on the using like the spreadsheet, if both of the numbers check requirements for a hypothesis test, if both numbers are greater than 10, there's like 2 cells that are like just, I don't know, they check the requirement. If they're both above 10, then supposedly you're good. But I think how they find that is by doing the n times p and the n times 1 minus p.
So it would be the same, right?
I think so. I don't know for sure if that's how they find those requirements, but that's what I think.
Okay. So the requirements for this would be satisfied for each one, right?
Yeah, I think so.
Well, it's kind of weird, but Kendra said false on hers.
Oh, really? So let me see. So it equals 10, but it has to be greater than or equal to. So that one would work. And then the other one is, let's see, 100 times, in parentheses, 1 minus p hat, which is 0.1. And that equals 90. So that one's good. I think it's, yeah, it's greater than equal to.
Okay, so
that one should be true.
The hypothesis test with that, so that's using p hat, and confidence interval is p, or no, the other way around?
I think the confidence interval is p hat. Dang, I can't. Let me look here. For a hypothesis test.
I think that because the other day we did the hypothesis test, and that was just, I think, was just p, right? And we're using p hat this time.
Yeah, okay.
Yeah, because I just have p on here.
Oh, okay. So it's on the remember at the summary of this section. It says the requirement for a confidence interval are n p hat is greater than 10 and n 1 minus p hat. That's for a confidence interval, and then for a hypothesis test, it says it's n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. So that would be for the hypothesis test.
Okay. So I'm gonna write this here somewhere.
So I think 4 and 5 are both true.
I think so too.
Either way, no matter which way we do the math, I guess it does matter which way, but really they're both greater than or equal to 10. So
yeah, 100 times 0.1 and 100 times 0.25. So
yeah. And I was looking at their video, the wedge video or whatever.
Yeah.
And I think we have to do both. I think they both have to be greater than 10 because they put and in between the two equations there.
Yeah. So, okay.
And yeah, they're both above 10. So. Okay. First degree of these 45 of the defendants were found guilty. 68.
0.75.
Yep.
So 0.75?
Yep.
Sweet. And then the confidence interval, we use just the standard 1, 2, 3, right?
No. For the confidence interval, I think they say for 90 is like 1.645. For 95, the 1.96, and then 2.58 for 99.
Okay. The reason I thought that was in the preparation assignment. I looked up the answers, And originally I got, a certain number with using 1.96, and it said that was wrong. And when I used 2, I got the right answer.
Oh, really?
So that was why I was questioning that. But I do remember in the videos they did use the 1.96. So that kind of threw me off. I didn't know. I thought that was weird.
Mistake on the book. I don't know. But I don't know. So.
See, yeah, on the, well, at least when they're using the, well, let's see here, I'm going to keep going. Yeah, they use 1.96.
Oh, okay.
In the book.
Yeah, in the book. That's weird. Yeah, I don't know why it was messed up.
All right.
Want to get it? Oh, empty.
Hi. Just 2.
How are you?
Good. I'm on a conference call.
He said that you have a lot of electronics in front of you, huh?
Yeah, I got my iPad and computer.
Tell you what.
So on this one, I got, with the 1.96, I got 0.64 and 0.86.
0.64 and 0.86. Okay. Oh, you know what? This thing that just downloaded. So I don't know if this is the. Oh, this looks like. What is this? It's in Excel stuff. I have no clue what it is. Oh, that's for the. Bunch of data I don't need. Oh, here we go. Come here. Come here. Okay, so they say you plug in your numbers here, and then. Oh, now you went down, huh? But you're just a big baby, huh? All right. Okay, so 60, 45. Yeah, that's what I got too, so. I guess there's not really a null. Yeah, I got 0.64 and then 0.86, so. Okay. Okay, let's see. So increasing the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval? I think if you do the sample size, if you increase the sample size, it'll decrease the interval.
Yeah, that's what I was thinking as well. I'm going to try this real quick.
Yeah, try it and see. Hey, where's my cup? Hey, you stencher, bring me my cup.
Yeah, so it decreases.
It decreases, okay.
Hey, that was perfect for
So bring me that.
On 9 and 10, are we using the same margin of error that we got above?
For 9 and 10, I think we're just supposed to find whatever works, or like whatever. Oh heck, whatever. Like what's the smallest amount of people or whatever. So what's the smallest n can be?
Well, that's the thing though. I have the thing for that. I have z over 2m. So z over 2 times the margin of error. But we don't have a margin of error on this.
Oh, let's see. That was for the
number 9, or that was for the
z over 2m. Where's I'm trying to see where that is talked about here.
Should be in at least the chapter summary.
Because for the confidence interval, we can just use actually.
Oh, we just have to meet the requirements.
Yeah, so it's
1/2. So 10
20
divided by 1/2. So yeah, 20. And then 100.
I think so, yeah.
Sorry, I overthought that.
No, because I was thinking the same kind of thing.
Yeah, it's just the requirement. So NP has to be greater than or equal to 10.
So if we're looking for the n, then we would use our z-score divided by our m or square that.
Yeah, if we know, yeah, if we're looking for that.
But this, we're just looking for the small. So yeah, okay, that makes sense. Okay.
Given that we have a margin of error, so
Yeah.
if we have, so yeah.
Drew.
What?
Drew, was the North Circle running when you got here?
Yeah, I believe so.
Go check it, would you?
What do I check?
Just see if it's on. If it's not, let me know.
What do you turn off or what?
Well, if it's not on, then it sucked the pump dry, and we'll need to restart the pump and start the bean circle down there.
I saw the bean circle down here.
Well, it should be right here, and I don't see the end gun going. Maybe I'm just blind. No, the pump, this North Circle is right here. It's right here by Jesus' house almost. Anyhow. Just, yeah, when you get a chance, just take a look. Maybe the engine shut off. Anyhow. Alrighty, sorry, Kyle.
You're good. You got some Mexican neighbors?
Yeah. Yeah. He's like my dad's hired hand when us kids are not around. Here you go.
Cool.
Come here, Squirt. Yeah. Hey, come here. Come here.
So the conditions for the test are satisfied, right? Or are you there yet?
Yeah. So the conditions would be, yeah, I would just do that.
No.
Okay, so
Yeah, please don't let her throw my computer around, please.
Yep.
Look at that.
no. Okay. Yeah, they work. Sorry. So P hat is G at 0.475.
I got 0.35, right? 38 divided by 80.
Yeah, I did that wrong. My bad. I got 0.475. I'm doing it wrong.
Oh, I did too. Sorry.
Okay.
Which might actually help what I was doing. The z-score, did you get negative 2.34?
Almost there here. And did you get negative 2.282?
I got negative 2.344.
0.344. Okay, let me.
So it's so 0.475 minus 0.6, you get 0.125 divided by the square root of 0.35 times 0.65 divided by 80. Right?
Sorry. Let me walk this one more time here. Because I just plugged it into my computer, but let me do the math. Okay, so so you do point. So Kyle, how did you set up the z-score? You did 0.475 minus 0.6 divided by.
Yeah. So.
What did you?
Yeah, and then that divided by the square root of 0.35 times 0.65 divided by 80. And so you basically, if you divide them out to two different numbers, it should be basically negative 0.125 divided by 0.0533. That's what I keep getting, unless I'm plugging something in wrong.
Let's see. So it's point. Because I think were you using 0.35 before? Because I think it's. Do we use 0.6?
I think you have to use. Yeah. So p hat 0.475 minus p, so 0.6. And you get negative 0.125, and then you divide that by the square root of 0.35 times 0.65 divided by 80.
So I got the divided by 80, but isn't it, because I was thinking we used 0.6. Don't we use the 0.6 for the P on that?
You know what, you're right. Let me do that again. Sorry.
No, you're good. Because I was thinking we used 0.475, but I wasn't doing that right, so.
Well, why was I getting 0.35? I'm lost. Sorry, dude.
No, you're good. I think when you maybe calculated something wrong for the initial P, the P hat.
Yeah, did you get negative 2.282?
Yeah, I think so.
Okay. Well, I'm glad you got that cleared up for me.
Yeah, no problem.
Now I will be more careful. So we failed to reject, right?
And then
you get the p-value of 0.011?
I haven't plugged it into my applet thing here.
Okay.
Really? Oh, goodness gracious. My calculator's being a pain. Let's see here now. .011.
Yeah.
Okay. Sorry about that. Yeah. Okay. And then
So Kendra, well, oh, we rejected then. Sorry.
0.05.
Must be tired.
Tired. So you got, what did you get for 15? Did you say fail?
Reject. That we reject the null because 0.01 is less than 0.05.
Okay, yeah, that's right. Okay. Yeah, my bad. I was thinking something else. I don't know what I was thinking.
I know, I did the same thing, so.
Oh, really?
And then I just looked at Kendra's answers here, and I just saw that that's not what she put.
Thrown off.
Looked at it again, and I was like, oh, wait. That makes sense. Okay. So for the Kendra, what Kendra put, I think the only one she put differently was number 4. She put true, or she put false. And we put true.
Oh, okay.
And so for number 16, we're going to say that there is sufficient evidence to conclude that water quality in the area has decreased, right?
Yeah.
Okay.
And I don't know. I think number 4 is true.
I do too. I don't see why it wouldn't be.
So let's run through them, and then I'll turn them in, and we'll see what we get, and then I'll email what we got and give it to
Kendra.
Give it back to Kendra. Yeah.
Okay.
Hold on here just a second. I'll drink this. We'll clean it. You've never cleaned a diaper? Go clean it. Just go clean it, you big babe. I'm not gonna help you. You need to learn how to change a diaper. Aren't you gonna have kids one day? My goodness, man. She hates a poopy diaper. Now go clean it. Oh yeah, tip her upside down so it runs down her back onto you. It's a great idea. Okay, sorry. Okay, so number 1 and 2 are true. Number 3 is P. Number 4 is true, and 5 is true. Number 6 is 0.75. Number 7 is 0.64 to 0.86. Number 8 is decrease. Excuse me. Number 9 is 20. Number 10 is 100. Number 11 is true. Number 12 is 0.475. Number 13 is negative 2.282. Number 14 is 0.011. Number 15 is reject the null. And number 16 is there is sufficient evidence to conclude that water quality in the area has decreased.
Yeah.
Okay. Let's see what we did. So it says 100%. So I'll just copy and paste this in an email, and I'll send it back to her.
Okay.
That way she has it, and
nice.
She has a good excuse to be gone. I mean, a wedding reception's kind of a big deal, you know?
Yeah, I told her to talk to the teacher.
Yeah. Plus, she did the work and gave it to us, so I think, I don't know. I'd be fine with just giving it 100%. So.
Whoa.
So what I'll do is.
Wait, why did I get 100? What? I got a 0 on this.
On which one? Oh, did you get a 0 for homework 16?
Yeah.
Yeah, me too. I think she put the due date earlier than it was due. And I think if you look really closely at like the right side where the grade is, there's like a little circular arrow.
Yeah.
I think that means you can retake it.
I sure as heck hope so. Well, it's weird because on here it says that it's due, Saturday at 12.
Saturday. I think she must have reposted that homework because it must have, I don't know, somehow gotten.
Okay, that's weird. Yeah, it says you can retake it.
So.
Well, that scared me.
Yeah, first time I saw it, I was like, oh, that's weird. Give me a 0, find what I do. But anyhow, okay. Yeah, I'll send those to Kendra, and then I'll post the not the picture. I'll post the video here, and we'll be set for the weekend.
Sweet. All right. So the other thing, we've got to decide on a study that we're gonna do.
Oh, that's right, huh? That's right. I didn't even read over any of that because we lost power, and yesterday I was busy all day, and so I hadn't even looked over any of that stuff.
Yeah. Well, honestly, we can choose whatever we want to.
But basically, we design the study, and then do we have to like collect data and everything and whatnot?
Yeah.
Oh, really?
So we design the study, we collect the data, we do all that other stuff. And so what I have to, my assignment is designing the study. So we have to choose what we're going to do, and I'm going to put it all together here and turn it in.
You have to do the whole. Oh no, you just do the design, the first part of it. Okay.
So, what did she tell you that you were doing?
Let me. Oh yeah. Okay, so I'm doing describe the data, and then take action. We have you doing those. Take action.
I'm take action.
No, I think she has me doing that.
Oh, you're take action. Okay.
Yeah. So describe the data and then take action are my two.
Okay.
So you know what? I think maybe the easiest thing is going to be to do something at church almost. Like, how often do you do family home evenings or something like that? Because it's hard. It's going to be harder for me to like see people and like pass out a piece of paper that has to do with like getting like survey stuff. Whereas Kendra, she goes to the MC, passes out a bunch of paper. But for me, I think church is probably be like the easiest. I just hand out a piece of paper and then have people fill it out.
Yeah, that's a good idea. Kendra and I were just talking about doing something like, how many M&Ms are in a bag, or how many, something kind of like that. But we could totally do something with the church. We didn't really think about that. That could be a good idea.
Actually, you know what? That might be easier. Something that's inanimate. That way we can control we can control the parameters of it or actually what's happening. Maybe that's actually a better idea, I think. I just think it'd be easier, to buy 10 bags each, or not even 10 bags. If we each had, well, I guess if we each had 10, that'd be 30, but.
Well, we were doing that ANOVA stuff, so we could do, each one of us buys, we could say 30 bags and just see what the difference is in it.
Yeah. Maybe we should get the fun size ones because that's a little cheaper.
Yeah, could do that too.
Yeah, maybe we'll do something like that. I don't know.
You're the one.
Go ahead.
We could do something different too, not just M&Ms, but like Reese's Pieces.
Yeah, Reese's Pieces are better anyway, in my opinion.
Yeah, and we could do, Reese's Pieces have three different colors on them, I think.
Yeah,
like orange and yellow and brown. I think those are the three. And so we could do something with colors with that, or we could do just the number of Reese's Pieces that are in each bag.
Okay.
Or whatever. I mean,
doing the number of Reese's Pieces in any bag is probably gonna be the easiest, but I don't think it's a big deal.
Yeah.
The other thing, let's see. I was gonna say you're the one that's kind of designing it. So I mean, we've kind of got an idea. If you just want to take something and run with it, then because you're the one that's writing the first part of it up, so I think that'd be something you get to decide rather than the rest of us.
Yeah, well, I think the idea is that we all decide on it, and then we
each do our part and get.
And then I kind of just have to write it up, make it look pretty. I think is the idea.
Okay, well, yeah. Why don't we do something like that with M&Ms? Kind of design the study. Basically, each of us will get 10 bags of the fun size Reese's Pieces or something like that, and then we'll just do the number inside or something.
Okay. Do they have fun size Reese's?
I don't know, actually. If they don't, that's not a big deal. We could do the normal size or whatever.
Okay.
So, but yeah, that'll be good, and then from there I'll do the describing the data. Actually, that'll be, let's see, there's design, collect. So I'd guess Kendra's collect, and then.
Well, collecting, we all collect, so.
Yeah.
And we all send that in.
Cool.
So describing, you would describe the data, put it in SPSS, and do whatever with it.
Okay.
Make inferences. Kendra's going to make the inferences and say what it means, what all that stuff is. You're going to say what we're going to do with that information, and then Kendra's going to put it all together and make it look pretty.
Sweet.
So it's really not that much. It's kind of easy.
Yeah, I don't think it'll be too bad at all.
We just got to agree on what we're going to do.
Well, I like the idea of the M&Ms. I think that's a good idea. It's pretty simple, basic. It's not difficult. So, yeah, I think that'll be good.
Okay. So are we going to do Reese's or M&Ms?
I say Reese's. It doesn't matter to me. It really doesn't. Whatever you or Kendra think would be good too. So
I think Kendra wants to eat some Reese's as well. So
okay, perfect. Alrighty, I'll get my hands on some then.
Okay. I kind of do have that question though.
And then are we each? Go ahead.
So the population of the study is going to be all of the Reese's fun size things.
Yeah, fun size or normal size. I guess the population would be all the Reese's Pieces bags in the whole world, I guess. I don't know. That, or maybe we're not all store, so yeah, it'd have to be at least in the U.S. All the Reese's Pieces bags in the U.S. Yeah. So, yeah, that'd be like the population, and then I guess we don't really have like a sample to match against because they don't really say how many's in it. They just kind of say.
Yeah. Well, that'll be the nice thing is we can use the Nova test like we were doing.
Yeah, just kind of.
And yeah. So I've got a question. So for the sampling method, how are we going to do that? Would it just be convenience?
Well, if you did like, I guess if you pulled out all the bags out of the box and you set them in a row and then you did a simple random sample, like computer generated it, that I guess that would work. But I would say the easiest would probably be like a stratified where you say, okay, I'm going to pick up every other one out of the box because I doubt there's more than 15 in there, 20 in there. So, and if you're buying 10.
Well, I don't know that you can buy just a fun size bag.
Yeah, I'm trying to think if I don't know if they'll even have a fun size. Or if it'll be in like a pack of other things is what I'm thinking. So.
Yeah, well, I think if they have a bag of fun size bags, then we could always, I'm going to select this bag, and that'll be the test.
Yeah, I think that would be okay. I don't know if we could. I don't know if I guess that technically it would be convenient because it's not computer generated. But if you computer generated random, then line them up, and I think you could consider that simple random.
Be a lot harder too.
Yeah.
Take your computer in there and all right, here we go.
Yeah. Yeah, I don't know. So.
Well, I mean, the test requirements is supposed to be simple random, but I think we can do it anyways without it being simple random.
And I think actually online, I think you could like go to Google and do like computerized simple random sample, and I think you can type in however many you think are in a bag, and then do computer, and it'll generate the numbers, and then you just take those numbers and then you separate the bags, and then you just pick the bags according to the number that was generated by the computer.
I guess that would work.
That way you didn't have to take your computer in or whatever, but yeah, so.
All right.
But yeah, I think I think that would probably work for simple random sample.
Yeah. Okay. Do you have the instructions up there?
Let's see the instructions for the our project or whatever. I mean.
Yeah.
Hold up, no. For design the study or for the whole thing?
Yeah, design the study.
Rick.
I mean, if you want me to, I can write it up and just send you all a copy of it.
Okay.
And I mean, if you all agree with it, then we can go with that. Or
yeah, I don't see what's wrong with that because you're assigned the design the study. So technically, I think you can do. I honestly think you could have free reign over doing what you think. You could check with us, but I mean, if it's your section, then you don't even. I mean, if it was my section, I'd be like, well, I could check with them, or I could just kind of do it what I think is best. So I think you'd be fine. But yeah, let me know what you think if you want, and I can kind of walk through it a little bit. Or I'm sure Kendra wouldn't mind either. So it's up to you. I think it's whatever you want.
yeah, yeah. I mean, well, I mean, it is the whole group project, so
yeah. So
it's
you
really
might send us a copy, and we can read through it, kind of review it, make sure there's no like little glitches or anything. Or
yeah, okay.
But basically, it says you have to have the research question stated correctly, the population, the null and alternative sampling method, and then describe in specific detail how your group will collect it, and then what the sample size is, overall organization and neatness of the document. That's how it's graded. So, yeah.
Yeah. Okay. Well, I don't know that the Reese's Pieces will. I don't know that they come in fun size is the only thing.
Yeah, I was thinking about it. I don't think they do. I think M&Ms do, but which means if we did Reese's Pieces, it'd be a little more expensive. It's probably $10 for 10 bags.
Yeah. Well, the nice thing about the ANOVA test is that, you know, we could each get different sample sizes as well, but
Yeah. So I don't know. But if you need any help, let me know, and I'll see if I can't help you. I don't know. You probably do it better than I do, so.
yeah. Well, it looks like the only fun size pieces bag type thing is the M&Ms and the so M&M peanut M&Ms, regular M&Ms. Those seem to be the only one. Skittles as well.
Oh, okay.
Or sweet tarts.
I was gonna say we could do any, yeah, any of those.
Wow, what's this? I don't know. Those are mini Reese's. Okay. So, I mean, are you all fine with the Reese's Pieces, or are you fine with it?
Oh yeah, I'm just fine with it. Big bag, small bag, it don't matter.
Okay.
we'll work it out. So.
And I think that'll be good too, because it might give us more of a range of numbers of pieces in there.
Okay.
A small bag.
I think so too.
A small bag might have a kind of more of a simple standard to it.
Yeah, I think so too.
Okay. All right. Well, let's do that then, and I'll design it, and I'll send you a copy of the stuff, and you all can say just what you think about it.
Yeah. Yeah, it sounds good to me. Take a peek.
All right. Sweet. All right.
All right. Yeah. Good luck, and let me know if there's even before you get done with it. If you need help with something, let me know, and I can help you out. Try to help you out at least.
Okay.
So.
All right. Well, sounds good.
All righty, Kyle. Good luck to you.
Yeah, you too. Have a great weekend.
You too, Stud. We'll see you.
All right.
All right.
See ya.